A quick video on molar mass and mass to moles conversions, which is going to help us then count the individual particles within a sample. First thing we have to understand is that molar mass is a way that we can actually count atoms without physically counting atoms one by one. It allows us to count a larger sample, such as a mole, by using a scale. The molar mass is basically the same as the atomic mass that is listed on the periodic table. In fact, it is the same. The mass that is listed on the periodic table is, as we've seen before, the average of all naturally occurring isotopes of that particular substance. It has also been therefore defined as the mass of 1 mole of that particular element when measured in grams. So, for example, on the periodic table, 1 atom of carbon has a mass of 12.011 AMU, or atomic mass units. By definition, 1 mole sample of carbon also has therefore a mass of 12.011 grams. This relationship applies to the entire periodic table. So when we're looking at the mass numbers on the periodic table, we used to refer to them as atomic mass units and therefore the number of subatomic particles within the atom. Moving forward, it is also going to look at and be able to help us determine the mass of a 1 mole sample of that particular element, which is called molar mass, and the units for that are going to be grams per mole. So looking at how do we use this in our mole calculations, if you take a look at our mole map here, you can notice that we're going to be focusing in on this portion here, the mass to moles conversions. In order to go from moles to mass, we're going to take this road over here, and we notice at the top here we have a multiply by capital M, and capital M is going to be the symbol we use for the molar mass of that particular compound. If we're given the mass of a sample, we want to do the opposite and go down this pathway here, which is going to tell us to divide by the molar mass. So I'm going to do a couple of examples to show you these calculations. Once we then understand this, it can link to everything that we've done prior. If I give you the mass, we then should be able to go to the smaller particles, and if I give you smaller particles, we should be able to go all the way up to mass as well. So the first question is, what is the mass of a 3.0 mole sample of carbon? In order to go from mass to moles, we are going to need to know the molar mass. So the molar mass of carbon, as we've just seen, is 12.011 grams per mole. We're asking for the mass, which is grams, so we want to go question mark grams is equal to 3.0 moles multiplied by 12.011 grams for each mole, or grams per mole. We're going to take 3 times 12.011, and we're going to get 36.033 grams. Notice that the moles cancel out. We're going to be left with our grams unit. As always, we're going to do a last thing. We're going to analyze and make sure that we have proper significant figures. Our value in the question has 2 sig figs. So we're going to take our final answer and convert it to 2 sig figs. There's your first, there's your second. The last one always gets influenced by the number that's after it. So it's 36 grams. The other question that we're going to look at is going in the opposite direction. And I would like to know how many moles of water are in a 452 gram sample. So I want to go from this time, I want to go from mass, which is my given value, to moles, and I need to convert through this bottom pathway here. So we need the molar mass of our compound. In this case, the molar mass of our compound is water. So we need the molar mass of H2O. Water is not an element, it's not found on the periodic table, so we're going to have to determine the molar mass through the individual masses of each atom. So we need 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen, which are the individual atoms that make up the compound. So it's 2 times 1.008 8 grams per mole for the hydrogen, plus 1 times 15.999 grams per mole, which gives us 2 times 1.008 plus 15.999 gives us our 18.015 grams per mole. So now we want to go question mark moles. We need to figure out how many moles is equal to 452 grams divided by 18.015 grams per mole. Once again, our grams are going to cancel because we're dividing, which is going to invert the units here. 452 divided by 18.015 is equal to 25.0902061 moles. A lot of digits there. Last thing always, go back to the original question, 3 sig figs. So our final answer has to have 1, 2, here's our third sig fig, which gets influenced by the next number here. So our final answer is 25.1 moles is the size of the sample of water in that particular sample.